A digit is a symbol representing a natural number. For example, in the base 10 positional numeral system, we have the digits 0, 1, 2, 3, up to 9. Of course, there are other systems we could use instead of this positional system. We could talk about Roman system, where we have the digits 1, 5, 10, and so on. Or we could just invent our own system. Let's say this is 1, this is 3, and so on. So one advantage of this system is what we're going to look at here now. So we could, for example, have one digit for every number. So let us put up the numbers here, 1, 2, 3, 4, 5. So we could have a digit for each. In the normal system we have, of course, 1, 2, 3, 4, 5, 6, and so on. And we could, of course, just continue in this fashion, adding digits to every number. But when we come to this next one, what should we call that one? Of course, it's very tempting to call it 10. But 10 is not a digit. 10 is a combination of digits we use in the positional system. So we normally don't use the symbol, digit symbol for this number. So we have to invent some, and often you use the digit A. Of course, you could say that A is not a digit, it's a letter. But we could use any symbol, but it's normal to use the letter A for representing the 10. And then the next one, of course, is natural to continue with the letters here. So these are, if we continue with digits, so all these are digits. So we can have one digit for each number. But eventually we will run out of symbols doing this way. So it's better to make combinations of digits instead. So instead, if we limit ourselves to these 10 digits, then we can start to make combinations instead of digits. So instead of just piling them up, continuing this way, giving a digit to every number, we can instead start to group them. So when we come here we have 8, 9, and then when we have 10, we don't write 10 here. Instead, we move it up one step. So this now represents one pile of 10, or of A. So instead of writing A, we have one of these piles. And we have 0 of single balls. So we write 1, 0, the digit combination 1, 0. Of course we call this 10, but it's a digit combination 1, 0. So the one here is one pile of 10, or one pile of A, and 0 single ones. And then we can continue in the same fashion. Here we have one of those piles and one single. Here we have one of those piles and 2 singles, and so on. So instead of just continuing to lay them all in one big pile, we start to group them instead. Continuing this way, we have here, for example, 1, 8, that we call 18, 1, 9. And then, instead of writing like this, we move up this pile here, so now we have 2 piles. So now we write this as 2 of those A piles, or 10 piles, and 0 single ones. And then we continue in the same fashion. 2 piles and 1 single, 2 piles and 2 singles, and so on. Continuing this way, then we come here to have 9 of these 10 piles and 8 single ones. Then we have 9 piles and 9 single ones. And then the next one, we don't put another pile here, but we take, when we fill this one, we move it up here now. So now we have one big of those piles. So this is a pile of piles. So what should we call that? We call those piles one of those. So you have one of those big piles. And how many of these piles do we have? These 10 piles. No, we have none. And how many single ones do you have? You have none. So we call this 100. So we have one of those piles, 0 of these 10 piles, and 0 single ones. Then we continue in this way. Here we have 100 pile, 0 10 piles, because we have none here. But now we have one single. So we continue in this way. And we continue this way to make digit combinations. Now, continuing in this fashion, we see that we will only need 10 digits to represent any number. So just make combinations of these 10 digits, we can represent any number. So we have single ones, and this we have called 1, 0 or 10, and this I call 1, 0, 0 or 100. And then the next step we come to 1000. So meaning we have one of this huge pile, 0 of these, 0 of these, and 0 single ones. So continue in this fashion, we can represent any number. So for example, these groups of piles, what does it represent for number? Yeah, we can, for example, start from the right. So you see I have 8, or 7, we have 6, 7 single ones. We have 5, 10 ones. We have 3, 100 ones. And we have 2, 1000 ones. So this represents the number 2357. And this means that we can write any number now as a combination of these digits or these piles. For example, this now means we have 2 times 1000, meaning you have 2 of these 1000 piles. We have 3 times 100, 5 times 10, and 7 singles. Or if you like, we could write it as exponents. So we have 2 of 10 to the power of 3. Since 1000 is equal to 10 times 10 times 10. So we have 10 of these, and then we have 10 of 10 of those, and then we have 10 of those. So we have 10 times 10 times 10, we get this huge pile. So we can write it as 10 to the power of 3. And same here, this we can write as 10 to the power of 2. Because we have, this is 1, this one pile of 10, and we have 10 of those, then we have 100. So this is 100, and then we have 3 of those, 300. And then we have 5, 10 to the power of 1, and 7. If you like, we could write this as 10 to the power of 0, because 10 to the power of 0 is 1, so we have 7 ones. And this is, of course, expressing any number in base 10, you call it, because it's base 10 here. So we express any number in base 10. More generally, we can of course write, if we have A, B, C, D, instead of just 2, 3, 5, and 8. And then we could have any number of digits here. So this now is a single digit, the 10 digits, 100 digits, and so on, up to whatever large number we have. So then we can write this in general as this: A times 10 to the power of n minus 1. And why minus 1? Because if you have n digits, then this 1 here will be 8 to the 10 to the power of n minus 1. And then we have 10 n to the minus 2. And so on, until we come down to x 10 to the power of 2, y 10 to the power of 1, and z 10 to the power of 0. So any number can now be written in these digits, in this positional system. So instead of having one digit for every number, we now only have 10 digits and write combinations of digits instead. And here, of course, I should have written a 7 instead. And these digits here now are unique. If we have two different numbers, there must be some digits that are different. So we have a unique combination of digits for every number we have.